So naming and writing formulas for ionic substances, there are a few rules to follow. Firstly, if we're naming an ionic substance, the cation, the positive ion, has to come first, which is almost always a metal. The name of the cation is unchanged, so if the metal lithium comes first, you just write lithium. The name of the anion, the negative ion, comes second, and we do change that. So if there's just one element in it, then the ending becomes ide, IDE. So if it was phosphorus on the end, it becomes phosphide, oxygen becomes oxide, sulfur becomes sulfide. If there are polyatomic ions, poly meaning many, atomic meaning atoms, so an ion with lots of atoms in it, and these ones are listed on your datasheet, the name is also there. Do look out for if you see the ending ATE or ITE, that means you've got oxygen and another element present. Now, if we want to work out the formula, then the first thing we do is look at the charge on the ions. Now, if it is in group 1, 2, or group 13 through to 18, you use your periodic table to work out the charge on that ion. If it is in group 3 to 12, then you would use your ion table or you use the name. So in your data book there's an ion table, it tells you the charges on those ones commonly, or if it's given you the name, so if it says the name copper brackets 2 oxide, that means the copper has got a charge of 2+. Why, if it's copper 1 oxide, then the copper in that case has a charge of 1+. So look out for those Roman numerals in brackets. Basically, to write the correct formula, what we need to do is figure out, well, how many of each do I need in order to get an overall charge of 0? Okay. One way of approaching that is to do a crossover. So you look at the charge, say on the sodium, and the charge on the oxygen, up the top right there. You take the 2 from the oxygen and you use that as the subscript for sodium. That's telling us how many sodiums we need. So Na with a little 2 after it, that little 2 refers to the sodium. The 1 from the sodium up top gets crossed over to the oxygen. So we need 1 oxygen. Okay? And we know that's true because from 2 sodiums we get 2 positive. From the oxygen, one of them we get 2 negative. Put them together, you get an overall charge of 0, which is what we want. Okay? Another example there with the aluminium and the oxide. Now that's slightly more complex. Okay? So aluminium would cross over the 3, oxygen would cross over the 2, and notice that the little number in subscript, and it does have to be in subscript, so that's slightly below the line, comes after the element, and it tells us how many of that element we want. Do note though that we always want the simplest possible ratio. So this crossing over can be useful, but be careful with it. If you did it with Mg 2+ and O2-, you'd cross over and you get Mg2O2. That's not the formula. What we're looking for is the simplest ratio. 2 electrons would be lost from magnesium. They'd both go to 1 oxygen. So our overall formula would be MgO. Okay, that's the simplest way of getting an overall 0 charge.